Hello, this is Rishabh Bandyopadhyay, and I will be presenting our work Doodle Your 3D from abstract freehand sketches to precise 3D shapes. The focus of this talk will be Sketch Control Gen AI. With Sketch, we have spatial control over generated media, either in the form of images, videos, or 3D assets. This, however, brings forth an issue. Lack of expertise in sketching often results in poor quality generated assets, as what you sketch is ultimately what you get. We address this core issue towards an overall goal of democratizing 3D content creation. For this, we identify regions in input sketches that correspond to shape parts and extract part-specific features from these sketches. Next, we use these part features for conditional generation of shape parts to generate the entire shape part by part. As a summary of our methodology, we start with part-aware shape modeling, where we divide a shape into a group of commonly observed parts. Next, we generate sketches corresponding to these shapes and obtain sketch regions that correspond to shape parts. Finally, we use our part disentangled sketch representation along with part disentangled shape representations to generate shapes from input sketches. We perform part-aware shape modeling by unsupervised division of a shape into a group of parts based on similarity across different shapes of the same category. We obtain the latent representation for individual parts by inverting each shape with a pre-trained decoder. Thus, for each shape, we have a latent consisting of m disentangled features, each corresponding to a particular part of the shape. We align these M features such that similar parts of shapes have similar feature indexing. In here, the shape on the extreme right and the shape on the extreme left are both matched with a template latent which is predefined. For matching these shapes, they are first inverted to form Z1 and Z2, which are aligned with the template latent based on their corresponding part indexing. Finally, we have an aligned latent space in which each part is indexed similarly. To construct synthetic sketches corresponding to 3D shapes, we first project 3D shapes to 2D images and then create abstract synthetic sketches of these projections. In addition to projecting the complete shape, we construct meshes of shape parts and project them in a similar fashion so that we can construct a part segmentation map of the projected shape. Since the synthetic sketches are constructed from these projected images, we can overlay these segmentation maps on synthetic sketches to form their corresponding part segment regions. For part-aware 3D generation, we invert 3D shapes into their part disentangle latents with a pre-trained decoder. Next, we train a diffusion model on these inverted latents to generate new latents that can be composed into 3D shapes by a forward pass of the same pre-trained decoder. To condition this generative modeling on abstract sketches, we train an encoder-decoder network that extracts part features from sketch through a segmentation task. Our model deals with abstraction in these sketches by explicitly looking for shape parts as sketch regions. We inject this part information from abstract sketches into our training pipeline to generate corresponding 3D shapes. In here, we use our encodings as query, while we use intermediate diffusion outputs as key value pairs, which are fed to our multi-head attention network. The most straightforward application of our work is abstract sketch to precise shape generation, where we encode sketches and feed these encodings to the diffusion model as query, and the diffusion model generates the latent that corresponds to these precise shapes. An interesting outcome of our work is also precise editing of 3D shapes by editing input sketches. We can perform these edits because of our part disentangled shape representation. Edited parts are automatically identified in the input sketch, and these edits are carried out in the 3D shape. More details, including quantitative and qualitative experiments and comparisons with previous work, are there in the paper. Our code is also released, which you can find in the project page. Thank you.